In this video, I'm going to be talking about vectors in a plane, and a vector has a magnitude and direction, where magnitude just means the length of the vector, how long is it, and the direction tells you where it's going. So like for example, this vector here can go A units to the right and B units up. That would make it land in this spot. Vectors are either bolded or have a little arrow on top of them. So for example here, the V has a little arrow signifying that it's a vector. And the way that they're denoted or written is that they have little brackety arrows similar to a point, or it can be in this vertical form where you have A on top and B on the bottom. The magnitude of the vector is denoted by this symbol here. It looks similar to the absolute value sign but with a double bar. The direction angle is the angle the vector makes from the horizontal axis. Since the magnitude is the length of the vector, as we spoke about previously, the length of the vector is kind of similar to the absolute value, so that is the same thing as saying the square root of a squared plus b squared. That's how you can find the length of the vector, which is the magnitude. For the angle is called the direction angle. So to find that, we can again use something similar to in the previous videos, where you use tangent theta, which is the angle, equal to b over a. So that means that our direction angle is the tangent inverse of b over a. If we look at the vector 6, negative 6, this means that it was shifted 6 units up and 6 units to the left. If we wanted to find the magnitude of this, we would have to do the square root of a, which is negative 6 squared, plus 6 squared, because 6 is our b. So if we evaluate this, we have the square root of 36, because that's 6 squared, plus negative 6 squared, that's another 36. And once we add this up, we have 36 plus 36, that's 72. And we can actually simplify this by breaking it down into two separate square roots. So a perfect square that goes into 72 is 36 and 2, because 2 times 36 is 72. So once we simplify this, the square root of 72 is just equal to 6 square root of 2. So this is our magnitude of the vector 6, negative 6. If we wanted to look for our direction angle, remember that theta is equal to the tangent inverse of b over a. So we can just plug in our b and a. In this case, our b is 6. So we would have the tangent inverse of 6 over negative 6, which is our a. And we can just plug this into our calculators and see what we get. Before we do that, you can also simplify this to the tangent inverse of negative 1, because 6 divided by negative 6 is negative 1. Again, remember to put your calculator in degree mode, and we get that our theta is equal to negative 45 degrees. If we plot negative 45 degrees on our axis, we actually get an angle in the fourth quadrant, but our angle is currently in the second quadrant. So in order to get our angle in the second quadrant, we have to add 180 degrees. That way it is in the correct place that we need it to be. So if we add negative 45 to 180, we get 135 degrees. So this is our direction angle. So now let's try to find the magnitude and direction angle for our vector w, which is 4, negative 3. A vector doesn't necessarily have to be called v, it can be of any letter. So in this case, our vector is w. And remember that magnitude is just the square root of a squared plus b squared. So again, we're just going to compute this. So we have that our a is 4, so we have 4 squared plus negative 3 squared. If we calculate this, we have that this is equal to the square root of 16 plus 9. 16 plus 9 is 25, which is equal to 5. So this is what our magnitude is. For our direction angle, let's first see where this coordinate lies. So we're going to go 4 units on the x-axis and then down 3 units. So our vector is in the fourth quadrant. And so since it's in the fourth quadrant, we have to remember that we have to double check that our direction angle is in the fourth quadrant. So let's find it. To find our direction angle, we have to take tangent inverse of b over a. Our B, we said, was -3, and our A was 4. So if we plug this into our calculator with degree mode, the tangent inverse of -3/4 is approximately equal to -36.9 degrees. So this is our direction angle, and -36.9 degrees is in the fourth quadrant, so this works. But if you don't like negative numbers, you can also add 360 degrees to this, and then it'll give you the exact same thing. So you can add -36.9 degrees plus 360 degrees, which is 323.13 degrees. Either of these direction angles is correct. The only difference is that one is negative and one is positive. But since they are coterminal angles, meaning that we went around 360 degrees, they are both the same. So you can always find the magnitude and direction angle in this way. All you have to double check is that your direction angle that you found and the vector are in the same quadrant. Hope that helped. Bye guys.